So what is universal gas constant? We know the equation PV equals to K, right? PV equals to K, where P is the pressure, P is the volume, K is the constant, and P is the temperature in absolute state. Okay. Now this constant K, it varies according to the mass of the gas. Now this constant K is dependent on the mass of the gas. Initially, I have told you earlier that K, that in Boyle's law and Charles' law, mass of a gas remains constant, right? So this constant K, this is dependent on mass. This is dependent on mass. So as the mass varies, this K also varies. Now, when 1 gram molecular weight of a gas is taken, right? When 1 gram molecular weight of a gas is taken, when 1 gram molecule is taken, 1 gram weight is taken, then K becomes R. K becomes R. We replace K with R, and this R is known as universal gas constant, and this R is known as universal gas constant. Okay. Why it is known as universal? Because from Avogadro's hypothesis, 1 gram molecule of all gases occupy the same volume under identical conditions of temperature and pressure. Right? Because according to Avogadro's hypothesis, you must have learned in chemistry that 1 gram molecular weight of all gases, right, they will contain the same amount of volume under identical conditions of temperature and pressure. So the value of R is remains same for all the gases. So the value of R remains same for all the gases. So it is known as universal gas constant, as its value remains constant for all ideal gases, because its value remains constant for all ideal gases. So now if you are taking, so this equation now becomes PV equals to RT. PV equals to RT. And if you are taking n gram molecule weight of any gas, then the equation, more generalized equation, becomes PV equals to nRT, where n is the number of gram moles of any gas, amount of gas. This can be represented as amount of gas, amount of gram molecules. Okay, for example, 3, 4, 5, 6, any number of gram molecules. Now this PV equals to nRT. This n can be again converted into PE is equal to small m by capital M into RT. Now, what is this small m? Small m is the weight of the gas in gram, weight of the gas in gram, and m is the molecular weight, and m is the molecular weight. Okay, m is the molecular weight, and m is the weight of the mass of the actual mass of the gas. So, if you divide the actual mass of the gas by its molecular weight, you get the amount of gram molecules the gas contains. Okay. So the value of R, you need to know the value of R. The value of R is equal to, remember this value, this may sometimes not be given, or it may be directly asked in your exam, 8.31 joules. Remember the unit also, joules per Kelvin per mole, per Kelvin per mole. 8.31 per Kelvin per mole. Okay. The value of R is 8.31 joule per Kelvin per